Okay, so this time I wanted to add another example to our data structures module. If you don't know about it, you can watch some of the past episodes. It's quite interesting because we have like string builders, string slices, dynamic arrays, linked lists, the hash table, and also priority queue. So quite a few data structures. And in this one, I use the linked list to implement a thread safe queue in some way. And yeah, the idea of a thread safe queue, or you can use it in a multi-producer single consumer problem, for example. And that's kind of the problem where you have a web server and you are running some computational intensive task. Let's say, I don't know, you do some hashing like we did in the other video where we were trying to crack passwords in C. So let's say you have a web server where you run something like that on a lot of examples, so it takes like 5 seconds or 10 seconds to get the response back, and you don't really want to let the user wait when they make a request and have them time out, because it's gonna time out right from the browser. So you kind of want to have an immediate response. Let's say tell them, okay, we put your task in a queue, and this is your position in the queue, this is your ID, come back in like half an hour when you feel like it, and try to see if the tasking is complete, something like that. And yeah, that's what I tried to simulate today. And yeah, let's see like an example of how it works. In this one, it's not really like that example is, I'm just using sleep to simulate like waiting, but it's gonna start the socket to web server on port 8080, and then we can use netcat. Haven't implemented uh, a front end like a client for this one. It's yeah, that this runs in the background. It's like a worker. It's gonna accept connections on port 8080, and yeah, we can basically uh, tell it to queue uh, task one. Like just a number. It's like some sort of type of task. It doesn't really matter. It's just that I wanted to have an extra argument there. So this will enqueue a task, and give it, if we run it, it's gonna give us back the ID of the task, and it's gonna say, okay, we enqueued the task because it was the only one, obviously, and then it's gonna start processing it. I mean, it's gonna enqueue the task and it's gonna process it because it's, I guess, the only task in the queue. But for example, if we spam it and enqueue a lot of tasks, you can see that it's gonna enqueue all of them, but it's gonna process them one by one. So then you can check also the status of one of the tasks. You have to pass in S and provide the ID of your task, and it's gonna tell you the position in queue. So now is the second one, and now it should be, 1, and now it should be 0. Should be indexed by 1, but we are programmers, so 0 means the first one in the queue. And yeah, it's still gonna say 0 after it's done. So yeah, probably should say something like done. I don't know. And yeah, we don't have like get get the result. It's just it processed it, it's done, and it's basically done. So yeah, that's how it works. And as I said, it's just a really simple mock to show how to implement a worker in C by using a linked list as the queue, and threads, pthreads, to make it thread safe, to add the mutex to enqueuing and dequeuing from the queue, basically. And yeah, I guess that's pretty much everything about how to use this kind of data structure for web server. It can be used for anything that's multi-threaded. and requires a lot of CPU usage, or it takes a lot of time to finish a task. So yeah, I mean, I guess if you are interested, you can also watch the full implementation in the following part. So see you there. So yeah, I started out as the usual C project with simple hello world file. I mean, I just import ts.h, but it's gonna be just the simple hello world. And yeah, I mean, what we have to do, as I said in the beginning, we have to copy, or I mean, we have to use the linked list data structure to simulate the thread safe queue. So we're gonna have this multiple source single consumer structure. Then it's gonna contain a queue. It's not gonna be a pointer. I'm gonna delete that. And it's also gonna need a mutex there, but we don't add it yet. We are gonna implement the web server first because I think it's more of a chore, to be honest, than the thread safe queue. So it's gonna be just the init. Then I'm gonna put there just the mock functions for enqueuing and dequeuing, and yeah, handling the queue basically. And there I created the structure item. It's gonna have an ID and kind, whatever. It's just to have some int values inside of it, just to have some data in some way. And yeah, here I created those two functions for enqueuing and dequeuing. We are gonna implement them a bit later. And now I was gonna implement the web server. So I was searching for some C socket examples. I yeah, I think it's searching for examples is better. Like you can look at the manual, and if you don't find the information about what you are searching for, the second best thing to do is search for examples, or maybe even asking ChatGPT to write you an example, right? So I mean, it's still an example. So it's yeah, I think it's a good way to try to do it. I mean, I already have some kind of project where I did sockets for an HTTP web server, but to be honest, I always forget the steps. Like the first thing, or I mean, it's not really about the steps, but it's more about which headers to include in your file, I guess. And those constant values, like those defines, are pretty hard to remember, I guess. So the first step is to create a socket. Then we would have to bind something to that socket, right? Like and this is what I forgot basically. And yeah, I guess we have to bind the an address and the port where we want to run the web server. So it's the function name is bind, but here I was trying to uh, pretty print the errors. I wanted to, instead of using p-error, to use my own fprintf, I guess, which I mean is the same thing, but yeah, just um, using my own function there, so whatever. And yeah, the next step would be to bind that socket to a port or to a server sock address. And yeah, let's see. So yeah, again, you can look at the man page to find which headers to include. I think that's a good way to do it. And yeah, now I can see that it's the text from the GitHub page was pretty small, so yeah, I mean, it is what it is. But yeah, here I was looking at my own implementation of the HTTP server, where I used quite a lot of other functions. I have no idea why I did that. I don't remember exactly how it was implemented, but I mean, it was a simple HTTP server. And yeah, here I created this sock address, and I was gonna set the fields to, yeah, I have no idea why you have to use AF inet. I guess it's like the IP type. It's like probably IPv4 or something. Then for the S address, I wasn't really finding any information in the man page, so it's pretty weird. But you have to use 0, basically. If you use 0, it means like all addresses. And then for the port, I used like whatever, 8080, doesn't really matter. You can use whatever. I guess it's there is also a limit for which ports you can use, but I don't remember exactly. Like some ports you have to use sudo if you want, like you need the root access to be able to use those ports. But I don't really remember. I think it's like ports below 1000 and something, and random random stuff, learning random stuff, I guess. So yeah, then we call to bind. Then we have to call to listen, make the socket listen. And I used only 10 concurrent clients, but you can use whatever you want there. I guess it depends on your system, right? You can use probably a million concurrent connection or something and it will still work. Actually, I think there is a limit. I don't remember exactly where you can find it, but I know it's a file in somewhere like slash user bin or something, where you can find the number of how many threads you can have. So probably that's the limit you can have for the connections. And yeah, after we listen, we need a while true loop where we are gonna um, accept connections. So the function is accept. It will get in the socket file descriptor and it will provide us the client socket. So where we have to read from to communicate with the client, right? And at the same place, if we write in that file, we send messages to the client, right? So it's abstracted away from us, like all the low-level stuff. It's like the connection to client is made through a file. Like you write to that file, and the client receives the data, and you read from that file, and you get the data from the client. So it's pretty nicely done, to be fair there. So yeah, I guess now we have the handle connection function. To be honest, I haven't seen what I put in that function. Probably it's like a hello world message if I remember correctly. But yeah, here I guess I realize I don't have netcat installed, so pretty embarrassing to be honest. So yeah, I mean I quickly searched on how to install it, whatever. Yeah, I don't really know why I don't have netcat though, because it should be like I guess. Yeah, I don't really know because it was always installed when I was using Ubuntu. I don't know. So yeah, now we actually are able to write that socket, and you saw that we got a hello world message on the client. So the next step would be to actually read from that socket, I guess. So yeah, I have no idea what I was doing here. Oh yeah, I wanted to add the handling of signal. So if you press Ctrl C to stop the application, it will run a custom signal handler. So that would be like that handle shutdown. And I use this keep running variable so that instead of doing while true, I do while keep running. And if you press Ctrl C, it's gonna change that variable to 0. So it's gonna stop the web server, right? So I guess it's a better way to gracefully shut down the server so that I think if we do that, we no longer get that issue with the address is already in use. Although the problem is was still getting it. I have no idea why. So I mean, strange to be honest. But yeah. So I also tried to use that shutdown function, but it wasn't really. Like it wasn't helping in the end. Like here at this point, you can see that it's working. It doesn't complain about 8080, but at some point it will start complaining again, so I have no idea how to fix that. But yeah, anyway, at this point we can start reading from the socket, and that means that we can send messages with netcat to our web server. And I guess in the beginning the message that I decided to send was just a simple int, just convert the buffer to an int and then do something with that int. Basically the int will be like task ID or something, but in the end you saw that I decided to have like task kind, whatever, it wasn't really used. Well, I guess I did it directly, so it was like the task kind, and I created this structure task, and now what we have to do is actually implement the worker. So it's gonna be, well, create the thread safe queue variable first, but we also need to create a worker at some point. So yeah, here we continue with the, the queue. So we enqueue the task. And yeah, I guess now I started to work on the worker itself. So the idea of the worker is it's gonna get a pointer to the queue, right, in its arguments. So it's gonna share this memory with the main thread, because since they're threads they share the memory, right? Like this is the advantage of using threads for this problem and not processes, because with threads you have the common memory. So yeah, you can share the pointer. And I guess I created a thread, passed in the C data structure, like a pointer to it, and yeah, I guess the adding the mutex in the queue, and now we can start to implement enqueue and dequeue, which I guess pretty simple, is just linked list push and linked list pop. So it's nothing special there, but you have to add those mutex lock and mutex unlock. So that's the idea. And now for the worker, the problem was that I was trying to dequeue when I didn't have any elements. So we also need a function to check if the linked list is empty. So I added that function, like, because if the list is empty, we don't want to run the worker, I guess. So yeah, I mean the list is empty when the head is null. So that's an easy enough check. So now we go back to the worker, and before we try to dequeue an item, we actually check if the queue is empty, and if it's empty we just continue. We add a sleep one. I guess it's not really needed, but you know it's like whatever. Wait for a bit before you try to access another task, I guess. So yeah, at this point I guess it was working. We were able to see the task being processed. So I added that message to see when it's enqueued. And here I created the task ID, which is gonna be a global variable, which increases like by one each time we accept a connection. So it's gonna be make task ID. It's gonna be 1, 2, 3, 4, whatever, like like a random ID. Uh, you can change that function however you want, I guess. So yeah, here I was displaying which task we are processing, because it's I think it's better to see that. So yeah, here we can see that we enqueued some tasks, and we were processing some of the tasks. So that's pretty nice. I mean, it looks like it's working already, right? So at this point, yeah, I was thinking, well, how about being able to also see some status about the task, right? So you enqueue a task, and you might also want to see if it's completed or not completed, if it's still in queue or not. So yeah, I used my implementation of string slice to tokenize by space. So we split the string that we get from the user by space, and we have to check if I guess the first token that we get is a queue, and if it's queue, then we try to enqueue what task to our queue. Nice play of words there, I guess. So yeah, here we have to copy paste our old code in that if statement, and on the other case, if we find an S, then we want to get the status of the current task. So I mean, it's still the same thing. We, oh yeah, so just, write to the client socket. We write to the client socket. I guess if we enqueue a task, we have to write to the client socket the task ID. And yeah, here I decided to just show just the task ID, not like any other text. So just the number, and then for the status, okay, I guess I wanted to see if the writing was working. So yeah, basically, if we try to enqueue one, it's gonna say us, it's gonna tell us the ID of that task. So then I went ahead and started working on the status, which is just gonna go through all the nodes in the linked list. And yeah, here I just I guess I changed from void pointer to task directly because I didn't really care about doing it generic, because it's just an example. It's not really the data structure, like you know the multi-producer single consumer data structure. Is just an example of how to make it using linked list. So yeah, and like at this point I was like, well, doesn't really make sense to make it generic. I'll just use struct item or struct task, and for status we need the ID, and yeah, as I said, we go through all the nodes, and if we find the ID, we return the current position. And yeah, here I forgot to go to the next node, so it's gonna, I mean, it didn't really crash, but it was the CPU usage was going up, and I was like, well, why isn't there any task being completed? And yeah, it was because I forgot to go to the next node. But I guess the idea is pretty similar to the other one. We get the ID from the message, and then we call to the status function, which gives us back the position in queue. Which, yeah, I mean, that's the only thing it does. So I guess here I figured out that I forgot about the next position, and I also saw that I forgot about the waiting for the worker thread to finish. So I also added that, and yeah, probably I'll see it soon enough. Yeah, I saw it. So yeah, here if we try to, well, I had a small bug in when using the string slice. I was using the wrong variable, so also fixed that. But yeah, at this point, C was starting to complain about addresses already in use, and I have no idea why, because I did shut down, I did close on the socket, so why would it still be running? Also did pthread join, so the thread was stopped. Like it wasn't still running in the background, the entire app or something. So strange, I don't know, I have no idea. So I fixed the wrong usage of that variable, and now it was actually working, as you saw in the start of the video. So it was showing the right positioning queue. So that was pretty nice. So yeah, I guess this was everything for the multi-producer single consumer structure, like for this small project. And yeah, I guess we managed to get what we wanted to, what we were trying to achieve. We implemented this data structure and a small web server to be able to visualize better how it's used. So we had a worker and a lot of small clients using Netcat to send some data to the server, and the server was enqueuing data in this thread safe queue, and it was using another thread which was running the worker to simulate processing using sleep. So, and yeah, we were also keeping track of the position in queue of each task, and if the user wanted to see the position in queue, they were able to use this s command and the q command to enqueue data. So yeah, I mean, this was basically everything for today. And yeah, I hope you learned something new with this small project. And I guess I'll see you guys in the next one.